In this video, I'm going to go over solving linear equations. So first of all, it's important to know the difference between an expression and an equation. An equation is going to have an equal sign, and an expression doesn't. You may remember of hearing about PEMDAS, which is the order of operations for when you're trying to simplify an expression. So some skills that will be helpful in this unit are to be able to use the distributive property and combine like terms. It's also going to be important to understand what the inverse operation is, and I'll talk more about that in just a sec. So if we're simplifying this first expression, I'm going to use the distributive property by multiplying the 3 to both of the terms in the parentheses. And then I'll just bring down the negative 6x. After that, I'm going to combine any like terms that I see. And so I notice that 3x and negative 6x are like terms because they both have an x. If I combine those, I get a negative 3x, and I'll just keep the 6. So this is an expression. If I look at the next problem, I have multiple like terms because I have x squared and x squared. So when I combine those, I get 2x squared, and then 5x and 3x. Those are also like terms. When you're using PEMDAS, you're using it to simplify the expression. So you work through the things in this order. You can do multiplication or division in one step and addition, subtraction in another. We always want to work from left to right. But what I really want to focus on today is solving equations. Because when you're solving an equation, you want to think about backwards PEMDAS. You want to work in the reverse order, and you want to use the inverse. So if we have addition, the inverse is subtraction. If we have multiplication, the inverse is division. So keep that in mind and think about that backwards PEMDAS. So if I'm looking at problem 1, I want to get x by itself. And so I'm going to work kind of from the outside in. Again, think about backwards PEMDAS, and I'll write it down over here. I would look for addition, subtraction first. I do have a plus 2, so I'm going to subtract 2 from both sides. Then I'm going to look for multiplication, division. And so I'll subtract 3 from both sides. And 9 divided by 3 is 3. That would be my final answer. Now, a great way to check your work is to plug it back in. So if I put that 3 in place of the x, three times 3 is 9, and 9 plus 2 is 11, which is what the right side said in the first place. So we just made sure that our answer was correct. Let's go ahead and look at an equation with that distributive property. What I'd like to do first is kind of clean it up a bit using that property and distributing the negative 3 to both of the terms. Remember that a negative times a negative is positive. And now I'm just going to apply my backwards PEMDAS. We're going to get rid of the addition, subtraction first. I'm going to scooch over here for a second so I have a little bit more room. Subtract 3 from both sides. That gives me negative 3x equals 9. And divide both sides by negative 3 to get negative 3. Remember, a positive divided by a negative is negative. Again, I can plug that back in and work it out to make sure that the left side equals the right side. Your equations don't always have to have x in it. They can have any variable. That x can be a t, especially if we're talking about time. It might have h if we're talking about height. It could have any variable at all, any letter. All right, let's work through some more examples. Feel free at any point if you want to pause the video and try these on your own. And of course, you can always go back and rewatch any of these problems. So again, I'm going to start by subtracting. I'm going to get rid of this 1 using that inverse operation, thinking about backwards PEMDAS. Now here's something that's new. We have 2/3 times x. Really what's happening here is 2 is being multiplied by x, and x is being divided by 3. So I'm going to do the opposite, which is multiply by 3 and divide by 2. What happens is over here on the left is that the 3's and the 2's cancel, and so we just get x. And so now I'm going to work this out. I've got 4 times 3, which is 12, and 12 divided by 2, which is 6. And again, I can plug that back in just to make sure that the left side equals the right side. Let's look at one where we have variables on both sides. What you want to do is you want to get all of your like terms separated. You want to get x's on one side and numbers on the other side. Doesn't matter if x's are on the left or the right, it's up to you. Now what I try to do is I try to avoid dealing with negatives. So if I see a negative number like this, I actually might add it over. If I don't have any negatives, I might think about playing out both of those scenarios and which one's going to avoid dealing with a negative. But honestly, it really doesn't matter. So if you're someone who likes to always get your x's on the left, that's fine. I'm going to choose to add this 3 over here. And I'm going to add the 8 over here. So it gives me 10 equals 9x. And we're going to divide both sides by 9. Now, if you can simplify this, great. If you can't, just leave it. That's fine. I'd rather see a fraction than a decimal. Let's look at a couple more. Now, you'll notice that these equations don't have numbers. And that's really where solving equations comes in handy. So if you're ever taking a chemistry class or a physics class or calculus, it's going to be really helpful to be able to manipulate a formula. So any formula that you would have ever learned in the past, maybe like area of a circle or circumference, sometimes we don't always have all of the information to get the variable that formula is giving us. So it's helpful to be able to solve for the other one. And we're going to use the same skills that we were just working on, where you want to get your variable isolated by using the inverse. So this one I have, distance equals rate times time. I'm sure you've heard of that formula before. We want to get r by itself. So let's say I have a real world example where I have distance and time, and I want to figure out what that rate is. I can divide both sides by r because rate and time, they're being multiplied. So the opposite would be division. Oh, I'm actually solving for t, which it's going to be the same either way. There we go. Solve for t, so I'm dividing by t. And so d over t equals rate. Okay, let's look at our slope-intercept form, y equals mx plus b, and let's say we want to solve for m. So the first thing I'm going to do is I'm going to do my addition subtraction. I'm going to get this b out of the way. Y minus b equals mx, and m and x are being multiplied, so the opposite is division, so I'm going to divide by x. So I could say m is y minus b all over x. Or if you wanted to, you could say y over x minus b over x. You can split it up either way. But that is it for solving equations. You really just need to focus on using the inverse. So knowing that the opposite of addition is subtraction, knowing that the opposite of division is multiplication, and working in that backwards PEMDAS order. So always look for addition, subtraction first, then multiplication, division. I hope that helps. Let me know if you have questions.